Hello everyone, and welcome to this fourth episode, where we will continue our work with the 909 Rimshot. In the last episode, we did the floor planning of the PCB, and in this episode, we will complete the layout. So let's get started and jump right into PCB editor. Okay, so here we have the layout of the board, or the floor planning of the board, seen from the component side. So if we look at the board from, this is the back side of the Eurorack module, that is what I call the component side. And on the other side we will have the jacks and pots and the button. Okay, so before we start to do the actual routing, we need to do one more thing, and that is to define which type of traces that we want to have in our design. And this is something you can set up yourself, and I would like to, apart from the default net class that we have a track width of 0.25 millimeter. I would like to add one track that is 1 millimeter, like so, and I would like to add a track that is 0.5 millimeter. Okay, so now we have defined our track widths that we can use in our design. And we click OK. And now we can see here that we have three different selections here. One is to use the net class default width, and the other one is the 0.5 millimeter, and the third one is 1 millimeter. Okay, so now we are ready to tackle the rat nest and do the layout. Okay, to start routing, we need to have some kind of strategy. And I have a set of guidelines, very simple rules that I try to use as much as possible. And one of the rules is that I try to use different layers for different directions when I route traces. So on the component side, I try to route in north-south direction, and on the top side, I try to route in east-west direction. And I try to use 1 millimeter traces for the power nets as much as possible. And if I need to, then I can go down to 0.5 millimeter. And I use, for interconnection between the decoupling capacitors near the ICs, I try to use 0.5 millimeter traces for this as well. And the rest of the routing is done with the default trace width, which is 0.25 millimeter. In which order should we route this then? I always start with the power nets first. So in this case, it will be something, let's say we have our plus 12 volt here. And if I press this button here, route tracks, and then I click on a track, then I can see, I can highlight the net or the rat nest. You can see the pads are highlighted. So this is basically where this signal needs to go all across the PCB. As I said earlier, I would like to use 1 millimeter for this. So, and then we have something that looks like this. All right, so the first net that we will actually route is this one. And since we are on the component side here, I will start with this net, like so. And if we continue here, we see that we need to go up here somewhere. And we also need to go up here. So I will actually do something like this. I will route this net like this, and here we can actually connect it directly to the pad. You see here I broke the rule the first time. And yeah, you can do that. This will probably not have so much implications. We have these traces here. These are connected to ground, and I will use vias for all my ground pads. So this is probably okay. But if you want to be strict here, and I can show you on this one, what you would like to do here is to switch to the top layer and connect the U3 IC. So let's do that. Now you can see that the line is blue, which means that we are on the top side. And here I want to connect back to the component side, the red layer again. And I will do something like this, I think. I will place via here, and then I can connect the pad. All right, so here we have connected the plus 12 volts from this rail here at the right. And we have switched to the top side or top layer, and we have something that is going horizontally here. And we go back to the component layer again, because the pad is only present on the component layer. If you have a through-hole component like this pot, in that case it will be possible to connect to it on both layers. All right, and as I said before, to connect the supply to the IC between the coupling capacitor and the supply pin, I would like to use 0.5 millimeter like this. Okay, let's click on the plus 12 volts. Okay, so we have not finished up here, so we will connect that one as well. I will adjust this a little bit, and if you want to sort of move a trace, then you highlight a line like this, and you press the button D. And then you see you can move it around, and it will still be connected at both ends. I do it like that. Okay, so now we have finished this part, and we have this part finished, and now we need to connect the supply voltage to the U1 IC here. I will place a via up here, and I will select 1 millimeter. I will do something like this. And then I will use the 0.5 millimeter again to connect between the IC and the decoupling capacitor. Now let's see where we are. So I click on the net to highlight the pads, and I can also see the rat nest here lights up, and I can see all the rest of the pads. Let's see if we can come up with something clever here. Okay, I think I will do it like this. Here is one thing. If you have this activated, this button, then it will override the setting you have here, and it will take the setting that is connected to a trace. Then it will inherit the trace with, and in this case don't want to do that, and instead we will use these thin traces. Okay, so now we have connected all the nets that are connected to the 12 volts, actually except this one here. And I will try to be consistent here. So I will switch to the top layer. And we can actually do the same here, because the next net we are going to route is the minus 12 volt. All right, so let's have a look what the minus 12 volt looks like. And it's a little bit easier. It's only connected to the ICs and to the bulk capacitor down here. So we can start by connecting that. We will do that since we are moving south-north direction here. We will go to the component layer, 1 millimeter track width, and we'll be connected like that. So we can route minus 12 volts on the other side. So I will actually route this one on the top layer like this. And then we will continue on this layer. Put the via here. Up here somewhere. All right, so we have the basic routing done here for all ICs. And I think actually that I will do the same for this one. Okay, let's have a look at this. All right. So you could argue that there's no reason to have it so close. It's still within the limits of the clearance, but why have it like that if you can very easily do something like this, and then you have a bit of more space here. Okay, so we have done the power nets. Next, I would like to approach the what I would call sensitive signals in a design. For example, if you have matched traces, if you have nets with high impedances, if you have a very low signal levels or something like that, then you have a trace that you don't want to sort of route around the board. In this design, we don't really have any really sensitive traces, but we have one net, and that is the one that I have named mix sum here. We don't have a super high impedance here or anything, and the signal levels are quite high, I would say. But I still want to be a little bit careful with this net over here. So if I click on that, then I see that all the pads that are connected to this net are in a straight line here. And to be honest, I had this in mind when I did the floor planning of the layout. So I was kind of trying to think ahead here a little bit. What we will do here is to switch to the default trace width, and we will route this. Next up, I would like to take care of those lines or nets that are sort of stretching across the PCB. You can see there are a couple of long leads here. And we can have a look at those. For example, this one, that is the trig signal. You can see that it stretches basically across the whole PCB. And I want to take care of that right away. Here we have another one, that one is not so bad. I can probably deal with that later on in the design. I will start route those, and then we can have a look at it and see what the result was like. Okay, so that is the trig signal done. I will probably clean this up a little bit, and I'm not so happy about this, but maybe let's see what the rest of the layout turns out like, and then we can change this if it's needed to. If there is room to move this outside the pins between the pot here, then I will do that. Otherwise, I did an approach that I would try to maintain the south-north strategy here. And then I used a couple of vias here to connect to the IC, and also to the discrete components down here, the resistors and the resistors. So that one is done now. So let's continue with the other one. Okay, so now we have routed that signal as well. Okay, so I think that we have dealt with the most important signals now. Now we can start routing the rest of the signals around the ICs and interconnecting all the passive components and everything. And then I will do that, and then we can go back and have a look at this afterwards. Okay, so here is an example of where you actually have to rip up some routing that you have done. And this capacitor here, I think if we flip that around, that will actually improve or simplify the layout a little bit. So I will do that. So I think the routing is done now, at least for all the signals between the components. Okay, so the next step here is to add the ground vias. And you see that we have a couple of pads here with the label GND, and those needs to be connected to the ground plane. And to do that, I select a track width of 1.5 millimeter, and then I add a track like this, and I terminate it with the via. And if you press the V button on the keyboard, then via will show up like this. And then you can place it, you don't want to drag it away like this. You will want to have it close to the via, but not on top of it or like this. So this is okay. Over here we have a decoupling capacitor for this IC U2, and here I would like to place 2 vias. And as you can see here, we have some on the top layer. We have a trace that is just below the pad, so it's actually quite difficult to put 2 vias here. So we will have to do something about this 12-volt lead first. And if you mark the trace like this and press D on the keyboard, then you can sort of drag it around, move it around like this. And now we have a clear area below the ground pad here, so we can add our vias. All right, so I will continue with the rest of the design. Okay, so now we have connected all the ground vias, and the next step is to add a ground layer. We do this by first selecting the top layer, and then we select this fill zone. And what we want to do here is to select which layer. We will start with this layer, and we will select the net GND because all our vias are connected to GND. And then we basically paint an area over the PCB like this. And one important thing is that you have to connect it to the starting point. And then you can see we have a blue hatched area here. And that is sort of an outline that we have applied a filled zone on the top layer. And by pressing the button B on the keyboard, then we will actually make the ground fill. All right, so I think we are finished with the bottom layer. What we can do now is to select the ground fill, and we also select the top layer. So we are actually connecting both the top and the bottom to GND. And we press B. You can see now we have also filled component side of the PCB with copper. It's always a good idea to connect these two together, and I do that by just adding a couple of vias in the corners, or if I see that there is an area where, for example, down here there is no copper at all at that point, we can add a via like this, and when we redraw the ground field, then you can see that this triangle showed up. So we have a small area here where we have ground as well. All right, let's have a look at the PCB in 3D view. So now here we can see the traces and the ground fields and everything. And it's actually starting to look really decent, I think. There are a couple of things we need to fix, and that is a couple of issues with the silk print. They are placed on top of each other, and it's, yeah, stuff like that. So that is the next step, to fix all of those issues and maybe add a logo and some revision text, and fix a couple of things on top here to add some text that is nice to have when you are debugging or verifying your design. All right, so that is the next step. But that is something that we will do in the next episode. So until then, thank you for watching, and I see you soon again. Goodbye.